Remember, it's always important when we talk about any regulation of a homeostatic variable that we have to look at the receptor level first. Receptors detect the change, control centers interpret the change, and then they, if needed, recruit effector organs to counter the initial change. So with respect to blood pressure regulation, we have modified mechanoreceptors in the aortic arch and the carotid sinus called baroreceptors. These baroreceptors are detecting blood pressure fluctuations at those two locations, and it will fire readings into our nucleus tractus solitarius. That's the same nuclei that we had included in our regulation of heart rate. Cranial nerve 9 coming from the carotid sinus to the nucleus tractus solitarius, cranial nerve 10 coming from the aortic arch. That nucleus now fires into another part of the medulla oblongata, the cardiovascular center. And the cardiovascular center, as needed, can utilize sympathetic nerves through the lateral horn of the spinal cord to innervate the SA node or the ventricular muscle. Or it can use parasympathetic fibers by way of cranial nerve 10 to innervate the SA node to bring about the counter changes needed to correct the initial fluctuation. So let's say, for example, we have a high blood pressure state. That chronically high blood pressure is going to be detected at the carotid sinus and aortic arch baroreceptors. And through cranial nerve 9 and 10 respectively, fire that information into the nucleus tractus solitarius. It's going to relay into the cardiovascular center. Because we're dealing with a high blood pressure situation now, blood pressure is elevated. We want to recruit parasympathetic fibers to innervate the SA node. In the same way that we discussed SA node innervation back when we did heart rate. Binding to muscarinic receptors, increasing permeability of potassium, and lowering that heart rate. Lowered heart rate in this case is going to help lower blood pressure. If blood pressure is deemed to be low by the baroreceptors of the carotid sinus and the aortic arch, we're still going to fire into that initial nucleus tractus solitarius with cranial nerve 9 and 10 respectively. Pass that on to the cardiovascular center, but this time recruit sympathetic nerves to increase heart rate at the SA node and increase contraction strength at the heart. Now, there are a couple of important items that we haven't included on this diagram that's worthy to keep in mind. One reason we haven't included them is you can only fit so much on one diagram. And the second one that we'll discuss is because we just haven't got all the information yet. As we go through other systems, we'll develop that feedback loop just a little bit more. Now, the first one that I'm talking about that we simply didn't draw on here is the blood vessels. Remember, sympathetic nerves, parasympathetic nerves also have an effect on systemic blood vessels. Think about all those skeletal, the muscular blood vessels. Sympathetic nerves tend to dilate those to decrease resistance to skeletal muscle. At rest, though, we're going to get more of a vasoconstriction. So remember, whenever we're talking about sympathetics versus parasympathetics, we can always recruit the blood vessels to play a role in blood pressure regulation as well. Understanding the relationship between pressure in the vessel versus diameter of the blood vessel. And it's generally going to be an inverse relationship. The smaller that blood vessel gets, the greater the pressure becomes inside it. The second one we didn't draw for lack of information right now is fluid retention. We had indicated that blood pressure and blood volume are also intricately related. And we can use hormones like ADH, aldosterone, ANP to manipulate blood volume as needed, thereby affecting blood pressure. Now, we didn't draw it on here. I wanted this particular section to only focus on mechanoreceptor/baroreceptor feedback. But if this loss of pressure was also associated with a loss or a change in osmolarity of the blood, like if we had a drop in pressure, but at the same time, the concentration of the blood increased, that's going to imply a dehydration scenario. Now involved in this particular scenario, we would start secreting ADH. We would secrete renin from the adrenal glands, the kidney, ADH from the posterior pituitary. And we would see it act on the kidneys to retain more water, therefore bringing that blood pressure back up. So we're going to include fluid volume regulation once we get through renal. And at that point, we're going to come back and look at this regulation again, now with that fluid shift in mind. So for now, just focus on the baroreceptor feedback, sympathetics, parasympathetics, and how we can manipulate blood pressure by only focusing on the heart as the effector organ. Thank you.